This is a video on mathematics for the students of class 9 and we are discussing the chapter Indices. Let us see the first question of discussion today. This is your question number 25. Here we have 2 to the power x is equal to 3 to the power y and 12 is equal to 12 to the power z. So we assume that 2 to the power x is equal to 3 to the power y, which is equal to 2 to the power z. All the three are equal to k. So we can write down 2 to the power x as k, and k to the power 1 by x can be written as 2. Similarly, 3 can be written as k to the power 1 by y, and 12 can be written as k to the power 1 by z. So we know that if I expand the third equation, that is 12 is equal to k to the power z, so we can actually break up 12 into the numbers with 2 and 3. So 2 times of 2 into 3 is equal to k to the power 1 by z. So I can write down this as k to the power 1 by x into 2 into k to the power 1 by y, which is equal to k to the power 1 by z. Now since bases are similar here, so the powers can be added. So this comes to 2 by x plus 1 by y, which is equal to k to the power 1 by z. Now since bases are same, so powers are also equal. So this can be written as 2 by x plus 1 by y is equal to 1 by z, or you can also write down this as 2 by x plus 1 by y minus 1 by z, which is equal to 0. Now what I have done is I have sticked to this form. 2 by x plus 1 by y is equal to 1 by z. So what I have done is I have taken 1 by y on the right hand side, so it becomes 1 by z minus 1 by y. On taking the LCM, it becomes yz, y minus z. Now what we can do is, in order to get to this form, we know that we have to find out the value of x here. So if I take the numerator, or if I cross multiply them, so x will come here, so this becomes our numerator. Yz will be multiplied to 2 and y minus z will come down as denominator. So we get this form: 2y by y minus z is equal to x. Hence left hand side is equal to, or it's not better, it's better to say the theorem as it is asked is proved. Let us see question number 32. Here we have been told that if p plus q to the power minus 1 into p to the power minus 1 plus q to the power minus 1 is equal to p to the power a, q to the power b, prove that a plus b is plus 2 is equal to 0, where p and q are different positive primes. So here we know that p plus q minus 1 and p minus 1 plus q to the power minus 1 is equal to p to the power a, q to the power b. So we are solving the left hand side, so we get 1 by p plus q into 1 by p plus 1 by q. On taking the LCM, we get q plus p by pq, and we know all these are equal to p to the power a and q to the power b. So this can be written down as 1 by p plus q into q plus p by pq, and on solving this we know that all these are equal to, if I solve this, we get 1 by pq as our answer, which can be written as p to the power minus 1 q to the power minus 1, which is equal to p to the power a and q to the power b. Now since bases are same, so powers are also same, so we can write down p to the power a is equal to minus 1 and q to the power b is equal to minus 1. So if I add up the powers, so a plus b plus 2 is equal to 0. So on solving this, we get that left hand side is equal to right hand side, hence proved. Next we have question number 34. Cube root of 4 to the power 2x minus 1 minus 1 by 2 is equal to 1 by 32. So on the removing the cube roots, we get 2 to the power 2 by 3 to the power 2x plus 1 by 2, which is equal to 1 by 2 to the power 5. On solving this, our equation comes to this: 2 to the power 4x, because 2 into 2x by 3 and 2 into 1 by 2 will become obviously 1 by cube root, because 2 and 2 gets cancelled. So you have 4x by 3 into 1 by plus 1 by 3, which will come up to like this, 4x plus 1 by 3, which is equal to, I have changed the fractions to negative power. So since bases are same, so powers are also same. So 4x plus 1 by 3 is equal to minus 5. So we can write down x is equal to minus 16 by 4. Hence 4 is the answer for this equation. Let us see the last sum for discussion today. That is, if 9 to the power n into 3 square into 3 to the power n minus 27 to the power n by 3 to the power 3m into 2 to the power cube is equal to 1 by 27. And we have to prove that m is equal to 1 plus n. So if we see this equation properly, all can be converted to the powers of or to the base of 3. So if I write down 9 as 3 square, so it becomes 3 to the power 2n, 3 square into 3n, and 27 can be written as 3 cube, which will become 3 to the power n, 3 to the power 3n, and we already have 3m and 2 cube. 2 cube we can write down this as 8. Now we have 2n plus n, so it becomes 3n. We have 3 square minus 3n. Okay, so now if I take 3 to the power n as common, so we are left with 3 to the power n. 3 square is already here, and 1 is taken as common, so this will become 9 minus 1. So we get our power as 3 to the power 3n by 3 to the power m. 8 and 8 gets cancelled, and we know that all this is equal to 1 by 3 to the power 3. Now we have 3 to the power 3 into n minus n is equal to 3 to the power minus 3. So we have 3 to the power 3n minus m, because when bases are same, so powers are also equal, minus 3. So I'm taking 3 to the right hand side, so it becomes n minus m is equal to minus 1. On solving this, we get to the form as asked in the question to prove, that is m is equal to 1 plus n, or n plus 1 is equal to m, hence prove. So this is all we have from this chapter. Thank you.